Good morning, good afternoon, good evening. Looks like we have a good global audience for this, so we're going to get started. So today's topic is an update on our Raptor platform. The last one we did was last year at the end of the year, and so we thought it'd be a good opportunity to get together and kind of go through what is new and what's planned for the Raptor platform and all the tools and products within. The agenda here, before we get started, I want to mention a few things about the GoToWebinar interface. There's a questions interface within the toolbar, and if you have questions during the webinar, go ahead and add those. There's Chris Ferrone's with me, and he'll answer questions, and I'll answer questions if they're topical during the webinar. Otherwise, we'll hold them to the end. So my name's Ben Hoffman, and I've got Chris Ferrone here. I'm a software team manager and the architect of the Raptor platform, and Chris is an application engineer who uses these tools, and he's also the product manager for Raptor Test. So we'll talk about Raptor Test later. As you can see, two main topics today is the tools and then the products. But before we talk about that, I wanted to kind of go over the platform and give an overview for anyone that hasn't seen one of these webinars or heard about the platform. Then we'll talk about each of the different tools. There's some name changes and some new tools in the lineup, and so we want to make sure that we go through each of them and kind of give an overview of what they do, and any new features. And then we'll talk about some new products and some updates to the information that we provide, Wiki and data sheets. And then we'll have some time at the end for Q&A. So a little overview on the platform. The team here at New Eagle, we've been doing model-based development for over 10 years now, and using primarily Modohawk to date, which is a great tool for model-based development. And as we've started to build out more and more production systems and doing things with modern systems like fleet management remotely, we've desired to have a solution that covers an end-to-end, a little less friction along the way. And so we've kind of built out a platform of tools and products that'll help us, and we call that the intelligent machine. It's got maybe remote monitoring, extensive communication, multiple CAN buses, maybe Ethernet with today's machines, distributed control. So this is our platform for doing intelligent machines, and we call it Raptor. These are the tools that are used during the development of a system. We start with doing rapid prototyping and controls development and displays, and that's Raptor Dev. Most of our systems today are comprised of what we call Raptor modules and also Modohawk modules. So we use Modohawk for the development of controls. One of the modules here you see is a Modohawk module. For ECUs that aren't supported by that, we use Raptor Dev, and especially for display development. Today we were able to do the display development within the Simulink tools to generate the software for displays as well as our embedded controls. After you've created software, you're going to want to do some calibration, and we have Raptor Cal for that. The Raptor controllers also support XCP, so if you're more familiar with third-party tools like Inca, Canopy, or API Vision, those are supported. We use Modohawk, Mototune for the Modohawk modules and for calibration. And then a lot of our systems today are heavily distributed, and so we have multiple modules that are communicating. We have a tool called Raptor CAN, and that is very useful for visualizing the data on a CAN bus, and also in certain scenarios you'll want to simulate modules, and then of course you want to capture data from the system and do some analysis on it. Further in your development, you're going to need to validate, and so we've built an automated testing tool that allows you to really streamline your development or your validation, and as you head towards production. Raptor Test, and then lastly, the Raptor Telematics. This is a GSM-based telematics solution, so you can remotely monitor. You can kind of connect to your system as it's in the field and capture data. You can even, for supported modules, you can do calibration and software updates over the air with that. It's a fleet management tool as well as a data collection tool. And also up here, service. We'll talk about Raptor Service later on. That is, as you send units out into the field, you'll want to probably have technicians go and do any diagnostics or troubleshooting, and also to do software updates. So we'll start with Raptor Dev. So this is the tool that's used for your software development, and we call it a automated build process. It's single click, direct to target. This really allows you to move quickly for rapid prototyping and also for your production controls development. Use MATLAB Simulink simulation to do fast development as you're getting started. Some people are even doing simulation of the full controls model with the plant model that's representative of the system. The simulation tools in Simulink are great for that, and the Raptor Dev tool hooks right into the simulation environment. Of course, if you're doing production controls development, you're going to want to have full calibration and fault management facilities, and those are built right in and automatically generated when you build your control software. A couple of things that we've updated in Raptor Dev lately. We've done some simulator support for our display targets so that you can do XTP calibration. You can do it running the simulator on the PC, and that allows you to really quickly develop your display targets. We've added a few new hardware targets that we'll talk about later. Via the software.neweagle.net interface for issues and feature requests, we've tackled more than 50 issues since our last update, last Raptor webinar. Added serial support to the VCAN 320 Lite. We've been updating our data sheets based on customer feedback to provide better content and make the modules easier to use. Things with touchscreens, user feedback, we've updated our template model to make the touchscreens easier to use. And recent feature, we've gone to node lock licensing, so we have the ability to use dongles and also to use node lock licensing. You'll see that on many of our products. We've gotten a lot of feedback that node lock licensing, not having to carry around the USB dongle, is a big advantage. Okay, so Raptor Cal. That's the calibration tool. As I mentioned before, we do support XCP on the Raptor targets, and so if you are already trained and have the third-party tools, you can use those. We offer a we kind of envision as a low-cost, medium feature calibration. Really streamline some of the calibration management. Got a echo. Yeah. Streamline some of the calibration management workflows. You can see here the workflows for working with calibration offline and online, transferring the calibrations from one software to the next. And then data logging. A couple of updates with Raptor Cal. So lately, the releases, we've been enhancing the stability. A couple of things with ease of use based on customer feedback for working within the tool. Some improvements for large data sets. As we start to roll this out into other larger projects, we have enhanced some of the workflows for big cal sets. The signal viewer, when you build your model, you can annotate calibrations with help, and so we've updated the tool to show that to the user. We've streamlined the display programming. So for all of our display targets, they're programmed via USB, and so we've made the process there a little easier. And again, with the dongle-free node lock licensing.
Just one thing to add to what Ben was saying about new features that are being added to RaptorCal. The built-in data logging feature is especially useful simply because it's built into the program and you can easily access it. I've had to work with other calibration tools that didn't have such a convenient feature built into the program, and you have to open up a secondary program. And the other thing that's nice about this data logging feature is that it can log signals in your model as fast as 5 milliseconds, as fast as time periods of 5 milliseconds, which is quite fast and very useful when you're trying to debug problems.
Thanks, Chris. So the thing he was mentioning about the speed of the logging, that's due to the DAC capability within XCP, and it's actually at whatever your foreground rate is. So if you've got a 1 millisecond foreground, you can log your data at 1 millisecond. So the next tool is RaptorCan, and this is particularly useful in distributed control systems. The day-to-day use of raw CAN data, it can be cumbersome, and so with this tool allows you to use a DBC as a primary lens through which you'll see your system. It allows you to simulate messages based off of a DBC. Of course, you can open the DBC file and see the signals and engineering data, and then logging, analyzing. Another neat feature is if you are doing on-vehicle development and you want to go back to your desk and replay scenarios, you can take your log and put it into RaptorCan and replay the scenario against your bench setup. That's particularly useful when you have limited access to a vehicle for testing. Chris?
Just to add to that replay log feature is especially useful if you've taken data during testing and you no longer have hardware available. You can essentially simulate hardware at your desk by replaying previously logged CAN data.
That's a good point. So updates, stability improvements. This is a constant improvement on all the products as we improve them over time. We've added an RCAN file format, and this is particularly useful for saving data, putting it back through the tool, analyzing it. This tool also was updated recently for node lock licensing, so you don't have to carry around a USB dongle. We've added a search feature, which allows you to look at big DBC files. We loaded in a J1939 DBC with hundreds of messages and realized we needed to be able to find things easily. We added RP1210 support recently so that you can use it with standard vehicle data link adapters.
Just to add a user story of sorts, previously I'd used Cavassar CanKing, some of which you may be familiar with if you use Cavassar hardware. And Cavassar CanKing is a program that allows you to view CAN data, but simply raw CAN data. And RaptorCan is so useful because you never really have to deal with raw CAN data. All of the data that you see has already been converted in engineering units, and you don't have to create any scripts on your own to convert that raw data into useful signals that ultimately you want to work with.
Thanks, Chris. Chris, I'll let you talk again. Raptor Test.
Sure. Raptor Test is a validation tool for model-based software. That means it's compatible with Raptor Dev and Motohawk software. Essentially, it allows you to validate your software either in your office or in a lab or even at your desk. And that's especially useful because if you're working with a prototype vehicle or expensive hardware that's cost lots of money to develop, you might not necessarily want to test your prototype software on this expensive hardware. So what you can do is you can create test scripts to simulate the rest of the hardware in your system, and that allows you to validate the control software that you're developing. The way Raptor Test works is there's a very easy-to-use graphical interface. Through that interface, you create linear testing scripts, run those scripts, and you get these very colorful-looking test reports that allow you to easily identify where your software has failed, where you need to go back in your code and fix a bug. And then you can also save these tests as PDFs, and you can use those later on in the development process.
Thanks, Chris. So Chris is an excellent person to talk about Raptor Test. As an application engineer, he's been using it in a lot of his projects lately. So also to point out, the test scripts, as you carry them forward, are a great way to do regression testing on your system. We found building up test scripts over time as you develop your system, and accumulating the test content over time is a great way to gain confidence in the system as you near production.
One more thing to add is, Ben was saying I've been using this a lot, and that's certainly true, and I can say that it's much more convenient to find bugs in your software at your desk and eliminate the vast majority of bugs in your software than as opposed to trying to figure out why your software is not working in the field, and you could be next to a really loud engine or in an oily garage. So it's quite a convenient tool to be able to leverage in the development process of your software.
Thanks. So moving on, after you validated your system with Raptor Test, Raptor Telematics, this is a plug-and-play remote monitoring system. It knows how to talk to the modules that we support. We have built this so that we've built it to plug into a system that has been built with the rest of the components we offer. So it knows how to do over-the-air ECU software updates for the modules that we support. I should say for supported ECUs, and then allows for remote vehicle monitoring, location history, fault reporting. On the next page, we'll see the web interface for the telematics.neweagle.net, where you can manage your fleet and retrieve data. So here's the web interface. It's got a simple login. On the right-hand side, I've blurred out some data to eliminate anything that's sensitive, but you can kind of see the location tracking. You can see where you can select a start time and an end time and download all of the data, including GPS for a particular unit. There are several levels of users, so a customer can have a fleet manager who's kind of like an admin, and then like a test user or a site manager that has certain units. Like if you're an OEM, you can have your fleet, and you can have customers that have purchased your units, and they can only see their units. You can push software updates through the update panel. You can retrieve any active faults here. You can configure the logging by adding a DBC file. So in the portal here, you can upload a DBC file, and that gets pushed down to the telematics units over the cellular network, and reconfigures them in real time if you add new CAN messages or you have some new messages that you'd like to log. And all the data that you retrieve is in engineering units, so it's easy to look at. And the format, when you pull a log, is in CSV, comma separated values, so you can import it right into Excel for any charting or anything you want to do for analysis. This is a new product that's coming later in the year. Raptor Service provides a simple interface for service technicians to diagnose and update fielded systems. It's a low-cost, simple interface for viewing controller data. You can clear faults. You can kind of create your own screens. It allows you to do, it allows a service technician to reprogram the controllers within a vehicle, compatible with RP1210 tools. It's a nice low cost, simple service tool. We do have for those that want to have a higher end service tool or more customized, we do have options for that. And you can, we have a webinar in July for that on custom service tools and service tools in general. So you might want to put that on your calendar. And I'll turn it over to Chris to talk about some product resources refresh that we've done.
Thank you, Ben. So we've completely overhauled our wiki and our website, and we've added a wealth of information on our entire Raptor platform. I'll show you how to navigate to our website from our homepage. So the wiki is an incredible resource, as many of our current customers might be able to tell you. If you go to neweagle.net and then you click in the top right-hand corner on Product Wiki, they can see my screen. If you click on Store, excuse me, not Store. If you click on Product Wiki, you'll see the homepage for our Product Wiki. It is, as I said, information on all of the products and software that we sell. On the left-hand side, you can see products by tool, and underneath that, Raptor. And this homepage for Raptor products gives an overview of all the different tools that we talked about today: Raptor Dev, Raptor Cal, Raptor Service, Raptor Can, and Raptor Test. And then it also offers more information on the hardware that we sell that goes alongside these software tools. So our Raptor control modules and our Raptor displays, as well as the telematics hardware that Ben had just talked about. One thing to point out is that there are also some videos on the wiki. There's this video in the top right-hand corner that gives a 6-minute overview of the Raptor toolchain, much of what we discussed today, but in a condensed format. So if you think you missed anything, you can also use this video as a resource. If we go to the Raptor Dev page, you'll have the option to scroll through all of the blocks that are available in Raptor Dev. If you're interested in learning more about the capabilities of Raptor Dev, you can browse through these different blocks and learn more about their features and how they might be used in application software. And there's also one-page executive product summaries on all of the Raptor products. If you think you're interested in Raptor Dev and potentially would like to purchase it, you can show this one-page executive summary. Is great for showing it to your boss to give them a great overview of what the product does, why it's valuable, explains the value proposition. And then there are some additional videos for using the product that explain how to program a display or program a module and go over basic installation. One more thing to point out, there are user manuals as well as release notes for all of our software and frequently asked questions, and further explanation of the different licensing options Ben had mentioned previously that we're now offering node-based licenses for many of our Raptor products. Alternatively, you could choose to go with a dongle-based option. There's full explanation here of the pros and cons of each option. And then another thing that we're quite proud of that we've updated are the data sheets for all of the control modules. We've been putting a lot of time and effort into making sure these data sheets are quite informative and useful. Before I get into the data sheets, I'll point out we've added a number of tables like this at the top of the pages. This particular table summarizes the whole suite of Raptor control modules and allows you to quickly identify what module we have available that might be appropriate for your application. So it summarizes the number of inputs and outputs, number of available CAN channels, low side drives, high side drives, etc. And then you can scroll down and find more details on every module in the data sheet. In the data sheets, we have a new summary page on the first page of the data sheet. Quickly highlights the most important points of the module, tells you what compiler you need, communication available, inputs and outputs. And then the second page discusses, gives a brief overview of what Raptor is, what makes a Raptor control module unique, explains the value proposition of model-based design. And then finally, there's plenty of technical details about your module and specifics about individual inputs and outputs. Last thing I'd like to point out about our website are the case studies that we have available. If we navigate back to the main New Eagle website outside of our wiki and click on applications and then case studies, you can browse through a number of user stories, success stories you could say, where we have used Motorhawk and Raptor control modules to help our customers. Those are the main highlights to the website and data sheets. So I'll turn it back over to Ben.
So I did want to point out on a couple of other things that we're doing with the data sheets. So the recent updates to the data sheets, this is one of the most recent updates. Actually, you can see from today. This will come out in the next Raptor release. A lot of what Chris mentioned, but customer feedback we've been asked to give a kind of an example wiring for the module. So how you might wire it with a main power relay, how sensors and actuators are wired in, maybe how you'd have a key switch. A little bit more explanation of how the power setup is for each module. This particular module has a couple of different battery banks, how the wake input works, and then kind of basic schematics for the different inputs. Some of our Raptor modules have very configurable inputs and outputs. For instance, this particular module, you're able to select the pull-up and pull-down or combinations within one particular input. And so we have example schematics for what the circuitry on the input and output is. This is a big improvement to the data sheets and make the modules more easy to use. You can see also the mechanical and pinout. So that's an update to the data sheet. Those will be coming in the next release. Should also mention the prior data sheets that we were providing with Raptor releases were not fully searchable, and so we had some feedback that making them full text searchable is useful. The data sheet having maybe 100 pins, it's difficult to find things when you need them, and making it searchable helps a lot. I should mention these are available on our wiki, as Chris showed, but they're also in the documentation folder inside of the installation directory. So when you install Raptor, you can go to the documentation folder and find the data sheets that are relevant and fresh for that particular version of the tool. So we've kind of talked about tools. The other main topic I wanted to talk about was the products. So the existing hardware that we support with Raptor Dev today, these are the modules. We have 3 displays. This is kind of a unique area for our model-based tools doing display development. And then we have 4 different, we call them HCMs. However, they're very general purpose and can be used for any time-based control. Chris has a comment.
One thing to point out, Ben mentioned we have 3 displays, and that's certainly true. The VCAN 320 and VCAN 800, though, can act both as displays and control modules. They have some amount of inputs and outputs that allows them to act as all-in-one standalone controllers. So if your application requires a display and doesn't necessarily need a large number of I/O capability, then the VCAN 320 or VCAN 800 might be a solution for you.
Thanks, Chris. So new hardware. We do have a couple of new hardware items that we're bringing out. So initial support was added for our BCM48 in Q1 of this year. It's a gateway, and it's got Ethernet, 4 CAN channels, and LIN. This is kind of a unique module for us because it is the first one that has Ethernet, which is a kind of a new communication network for both industrial control and automotive. So we rolled that out earlier in the year. It's got a good amount of flash memory, so you can have a pretty extensive program. It does have I/O, so it can be used both as a communication gateway and as a controller. Coming in the second half of 2015, we've got our GCM 196. This is a rugged automotive grade control module. A lot of I/O. It's got 3 CAN channels. This is a pretty hefty general purpose controller capable of complex time-based control scenarios. We have a new communication solution. We're developing this presently and expect it to be available in the second half of the year. This is a Bluetooth to CAN communication adapter, and so you can communicate to your system without wires, both from your PC as well as mobile devices, so a tablet or a smartphone. We have prototyped Android apps to date and also connected it with our PC. This will be a low-cost, production-capable Bluetooth to CAN solution. RP1210 compliant drivers for industry service tools. It's an exciting little communication adapter.
This will also have a USB option, so you could use this just like you would use a USB to CAN interface that you might currently use today, like Kvaser products. So you'll have flexibility to use either Bluetooth or a wired connection.
That's good point. So this is what should be coming online shortly, and we're excited to be able to have less wires tied up with everything. Our PCs, when we connect to the system with all the dongles and cables, sometimes you have to have hubs, and it it'll be nice to not have so many wires. So that was kind of what I wanted to cover today. We do have a number of questions, and we do have time for questions. So if you do have questions, go ahead and type them in. We're going to start looking at what we've got here. So we have a question about one of the controllers on the left side of, let me see if I can find where that was. Probably should have got. Okay, yeah, it looks like this is the 3620 here. We call it the HCM ARM4 70 pin 1401. That's this one right here. This top one here, 3620. I think there was a question about the limitation on the logging, and I think I covered that. The XCP logging that we have in our tools is based on the data acquisition feature of XCP, and we run the handler for that in your foreground. So if your foreground is 5 milliseconds, that'll be your limit for the speed. Now I should mention, you know, the way that the DAC capability works in XCP. The tool will go ahead and tell the ECU what data is required and what rate, and then the ECU will send that out without being prompted at the specified rate. Now, at 5 milliseconds, that's 200 messages a second, and so you can only have 5 messages, 5 frames going out at that rate. So 200 on a 250K bus, that's 2,000 messages a second. So you start to get a limit there. If you were to do 1 millisecond, that's 1,000 messages a second. You could only have 2 frames on a 250K CAN bus. So you have to kind of watch how you schedule things, because you can fill up your CAN bus with the logging pretty quickly. So there's a question about raw CAN data in Raptor CAN. Yes, you can see the raw CAN. It does have the capability to look at raw CAN, which it is still useful, but as far as analyzing data, we found that if you're going to want to look at the data on your bus, if you have a DBC file, it's most useful to look at the CAN bus through the lens of a DBC file, because you get engineering units. Oh yeah, I should read the question. Okay, there's a question about the Raptor telematics. In the can you program a GCM with that? Each ECU is supported on an individual basis. You can contact sales@neweagle.net for the support of different ECUs with the Raptor Platinum telematics level. We do support programming of certain ECUs over the air. The other part of that question was, can you log custom CAN signals from another controller using Raptor telematics? The Raptor telematics gold level, which is the kind of the base level, does support any logging of any CAN messages with the DBC file. So you use a DBC file to specify the messaging that you want to record, and you log that, or you load that into the telematics web interface, and the DBC logging configuration is sent down to all the telematics units that you fielded, and the logging is automatically updated, and the new data starts showing up on the web interface, usually within a few minutes. So with Raptor telematics, can you read any parameter that you can see with Raptor Cal, or do you need to be sending it over the CAN bus? Presently, it's mainly DBC related. So anything that you could see through a DBC file. In future versions of the product, we do envision having the XCP calibration support, so we could reach in and look at adjustments and measurements within your model, but that's not currently supported. There was a question about the software tools and licensing. Am I correct in my understanding that each of the software tools are licensed and sold separately? That is correct. If you go to the web store on neweagle.net, you can see each of the products, each of the software tools there. We do have the ability to provision your license dongle or your node lock license over the internet, so we can add licenses very quickly, but they are licensed individually. There was a question about the do you have an improved data sheet for the GCM 196-1793? That's a new controller that it's this one here. I'll show the GCM 196. You should be able to find that on our website. We will be rolling out data sheet improvements as the development continues. Like I said, this is coming out in second half of 2015. There's a question about Raptor Test. I'll let Chris handle that one.
Sure, thanks, Ben. Question is, how do you compose test cases in Raptor Test? And the way you create tests is you access overrides and probes in your module under test or coordinator module. That's a second module that you might be using to simulate additional hardware in your system. And you set those overrides to certain values and look at probes farther downstream in your model to see if the probes are reading values that you might expect given the values that you set the overrides to earlier in the test process. And the second question is, should the test cases be in a predefined format? No, Raptor Test is very flexible. You can create any test you want given the signals in your module under test or coordinator module.
Okay, a question with the CAN to Bluetooth. With the CAN to Bluetooth module, can you see info on a tablet or smartphone similar to what you can do with VCAN displays today? So at this point for the CAN to Bluetooth, we have prototyped an Android app that is able to see the raw CAN and show kind of a rolling CAN viewer. We're not envisioning an application development environment for this CAN to Bluetooth for any smartphones or anything. It would be more like an adapter that you can develop your own applications with. We will support it with our PC applications and future potential mobile handheld or tablet applications, but we don't envision having like a VCAN display environment for an Android device at this point.
Just to add to what Ben was saying, you certainly could create similar looking displays to what we currently develop in the Raptor, in the VCAN displays that we use right now, and you'd have to develop those displays using the Android environment. So in terms of appearance, they could certainly look similar, and you probably have more capability in developing Android displays because that's a much more widely used programming language than Raptor Dev.
Thanks, Chris. The question, can I transfer a dongle license over to a node lock license? Certainly. We do support that. You could send a request to support at neweagle.net. Now I should mention for the Raptor Dev tool, node locked licenses are supported beginning in 2014B003. So if you need to be using an earlier version of Raptor Dev, you still need to have a dongle license. A question about the GCM 196. The question is, it has 59 low side outputs. How many can be active at once? And the question is, how much current can it sync at a given time? I'd have to look into the details on that. I think it'll be in our updated data sheets coming out. if you want to follow up with support@neweagle.net on that question, that'd be a good thing to do. The question is the GCM 196 being used on any current automotive environment? This ECU is a rugged production controller, and it is used widely. A question here: how will BlueJ USB work? It plugs into the 9-pin connector. Will the Raptor apps on devices support this tool? Yeah, so it'll be very similar. Its use would be very similar to existing CAN to USB today. You will, for instance, if you have one of our existing CAN cables that has a DB9 on it, we'd have an adapter that goes from DB9 to the 10-pin hub. And so that is how you get from DB9 to the CAN bus. The BlueJ will also have that. It's got the DB9. I'll show you the picture of it here. It's got the DB9, and you would use one of the DB9 to 10-pin SmartCraft hub adapters to hook that into your system. Okay, it looks like that is all of the questions that we have. Yep. So thank you everyone for joining. I would say if you have any questions that you think of after one question just came in. The GCM 196, does it do peak and hold? It's a general purpose controller. I'd have to look. I know that it can do PWM, but at this point it's a general purpose control module, so it's not used for anything like injectors or anything right now. Okay, so I would say if you have any questions that come up after the webinar, you can go to the wiki. It's at neweagle.net/support/wiki. Or you can send requests to support@neweagle.net. Thank you all for joining, and look into on our website at the upcoming webinars. We do have we try and do monthly webinars, and we do have a great webinar on Motohawk in June, and we scheduled a webinar on service tools for July. So be sure to tune in for those. Appreciate your attention and joining in today. Thanks.